So first, let's give a quick recap of the tagging problem. So remember, we considered a couple of very important examples of tagging problems much earlier in this class. And the first one we looked at was part-of-speech tagging. So the problem here is to take a sentence as input and to provide an output where each word in the sentence now has an associated tag. For example, profit is a noun, sword is a verb, at is a preposition, and so on and so on. So abstractly, the problem is to take in a sequence of words as input and to produce a sequence of tags as the output of this model. So each word gets a single tag. The other important tagging problem we looked at was the problem of named entity recognition. So in this case, the input is again a sentence, and the output from the model is a segmentation of that sentence, where we identify important segments corresponding, for example, to companies, such as Boeing, locations, such as Wall Street, or people, such as Alan Mulally in this particular example. And we described how the named entity recognition problem can also be framed as a tagging problem. Let me just remind you of that, where each word is tagged with one of a number of possible tags listed down here. For example, some words are tagged as NA, meaning that they're not part of an entity, whereas other words are tagged as the start of a company, or the continuation of a company, or the start of a location, the continuation of a location, or the start of a person and the continuation of a person. So that's just a reminder that we can frame this named entity problem, this named entity recognition problem, which is a segmentation problem, actually as a tagging problem. So as before, we're going to treat this problem as a machine learning problem, and so our goal is the following. We have some training set which consists of perhaps a quite large quantity of example sentences where each sentence has the underlying tags marked, like this. And from this training set, we need to induce a function or an algorithm that maps new sentences to their underlying tag sequences. And in, I think it was the second week of class, we saw hidden Markov models. And the Viterbi algorithm. As one way of achieving this goal. So recall, in hidden Markov models, we would read off parameter estimates by taking counts from our training examples, and then for a new test example we would use the Viterbi algorithm to find the most likely tag sequence under the underlying model.